Hello everyone and welcome to this video. So for question 1, I've got the picture in the bottom right corner here, and we have been asked to determine the resultant force and the angle using the head to tail method. Now I really enjoy this head to tail method because all we need to do is just use a ruler and a protractor. So we need to have our starting position. So I'm going to start over here. Now I need to look at these numbers, 7 newtons, 10 newtons, and 6 newtons. So a scale of 1 to 1 will be sufficient. So I'm going to say scale up at the top here is going to be 1 centimeter will represent 1 newton. You need to show that to the teacher. Next, you need to choose a force, either the 10, the 7, or the 6. It doesn't matter which one you start with. I'm going to start with the 10. So the 10 newton needs to be 10 centimeters long at an angle of 30 degrees. So I've gone ahead and I've placed my protractor on the little dot that I made, and now I'm going to measure 30 degrees from the left hand side. So if I do that, I will end up with a dot, or 30 degrees would be somewhere over there. I then take my protractor away, and then I need to draw a line connecting those two dots, but it must be a 10 centimeter line. And so there I've connected my ruler, and so I'm going to do a 10 centimeter line. And so it will look something like that. You can see the arrowhead that I've drawn. The next one that I'm going to draw is the 7 newton. So remember that I need to start at the place where I have just finished. So this area here becomes my new starting position. So there I have placed my protractor on the position where we just finished, and now look at how this 20 degree is measured. It's measured at 20 degrees relative to the right hand side like that. So I'm not going to look on this side, but rather I'm going to go up on this side, and so that's going to be 20 degrees. Then what I'll need to do is take my ruler and connect those 2 points using a 7 centimeter line. There I've positioned my ruler, and now I'll do 7 centimeters. So you can see how that line has been drawn. And then the last one that we need to do, because we've done the 7 and we've done the 10, now we just need to do the 6. So this area here becomes the new starting position. So I have flipped my protractor over because I see that the 40 degrees is measured downwards like that. So I'm going to measure 40 degrees on the right hand side. And so that's going to take us over there. Now I need the ruler, and then I can draw a 6 centimeter line. There we go. Now that I have drawn all of the lines, in order to determine the result, I need to go all the way back to the beginning, this point over here, and I'm going to need to connect a line going from that point to the very end, which is where we just finished off over here. And if you had to connect that, you get an answer of around about, I would say that's around 4.5 centimeters. So if you're getting somewhere around there, that would be good. I would say anything between 4.1 maybe and 4.6, that should be okay. Because of course when you're doing a construction, it won't be perfect. So I'm going to say that the answer is, I'm going to go with, well, because I know the correct answer based on mathematical calculation, I'm going to put the answer as 4.3 centimeters. That is what it's supposed to be, very close to that. So because it's 4.3 centimeters and our ratio is 1 to 1, we can say that the answer is 4.3 newtons. But now, guys, they would like the resultant force, and they also want the angle. Now, if I look carefully at that red line, I can see that the angle is probably going to come out somewhere over here, which is around 57 degrees. However, I know that the correct answer should be around 55 degrees. That is because I've done the mathematical version. And so the 57 I'm obviously getting because it's not perfect. So if you had to get 57 in a test, you would probably get all your marks. So you should try and aim for 4.3 newtons at an angle of 55 degrees, and that's going to be north of east. The reason I say north of east is that we are measuring that angle relative to this line over here. And so this is the west line, because you can see that it's going towards, the east line, sorry, and we are measuring towards the top of that, so we're measuring north of that. So we'll say 4.3 newtons at 55 degrees north of east. In question 2, we are going to do the same drawing, or we have the same situation as question 1, but we are going to solve it by not using a construction, but we are rather going to use mathematics. So remember, what we need to do is we need to take each of these three forces, the 10, the 7, and the 6, and we need to break them up into their horizontal forces and their vertical forces. I'm going to start with the 10 Newton. So I'm just going to show the 10 Newton. I'm going to say 10 Newton. Let me do, now for the 10 Newton, we would have to use a triangle like this. Can you see that? There's a nice triangle. Because now we can use trigonometry. So let me quickly draw that triangle over here for us. And we know that that's a 10 Newton like that, going there. And this is a 30-degree angle. Now, if we use trigonometry, we need to remember SOHCAHTOA. And I'm going to call this x and y. If I look at x, I know that that is the adjacent. And if I look at the 10, that is the hypotenuse. So cos will be the best. So I will say that cos 30 is equal to the adjacent over the hypotenuse. I will then multiply the 10 over, and I will find that x is going to be equal to 10 multiplied by cos 30. And so that's going to give an answer of 8.66 newtons. And if we just look at how the 10 Newton is orientated, we would know that that is going to go to the left. I'm now going to work out y, which is the vertical component. And to do that, I will realize that y is the opposite of this angle, and 10 is the hypotenuse. So I can then say that sin 30, because that's opposite and hypotenuse, is equal to y over 10. I can then get the y alone, and what I would find is that that'll be 5 newtons. And we can look at this orientation, and we should realize that that is up. So we have now completed the 10 Newton force. I'm then going to do the 7 Newton force next. So I'll do that one over here. So for the 7 Newton, we have a little triangle that would look something like that. I'll draw that over here for us. So that's 7 newtons and 20 degrees, and then I'll have x and y. Then I'm just going to use the same technique, and from this triangle I can see that it's going to be cos for the x and sin for the y. It won't always be like that, but for this one it will. So we can say that cos 20 is equal to x over 7. We then find that x will be equal to 7 multiplied by cos 20, which is 6,58 if I round off to 2 decimals. And if I look at the arrow, I know that that's going to go to the right. Then I do the vertical component by using sin. So I say sin 20 is equal to y over 7. And then I just multiply 7 with sin 20. And that'll be 2.39 newtons. And if I look at the orientation of this, it's going to go upwards. And then lastly, we are going to do the 6 Newton force, which I will do over here. So the 6 Newton has a triangle that would look like that. So I'll draw that. There we go, where we have an angle of 40. We have a force of 6 newtons, and of course we need to find the horizontal and the vertical. So once again, cos is going to get us the horizontal, and sin would get us the vertical. So I'm going to go cos 40 equals to x over 6, and then to get x alone, I would multiply 6 by cos 40, and that's going to give us 4.60 if we round to 2 decimal places. And this arrow is going to go more to the right, so I'm going to say right. Then to do the vertical, we're going to use sin. So that's going to be sin 40. It won't always be like that, so just look out each time. But for this one it will. So sin 40 is equal to y over 6. I would then get y alone by multiplying 6 by sin 40. And that'll be 3.86 newtons. And that's going to go down, actually. If you look at the arrow, that arrow is pointing downwards. Alright. So there we now have the 10 Newton, the 7 Newton, and the 6 Newton complete. Now we can put everything together. So let's look in the horizontal direction. So I'm just going to say horizontal. And you need to choose a positive direction. I'm going to choose to the right as positive. So that means we're going to get 6.58, which is to the right, plus 4.6 minus 8.66, because that's going to the left. And if we go work this out, we get a final value of 2.52 newtons to the right. Because our answer is positive and we chose right as positive, then it means to the right. Then we are going to look at the vertical. So we're going to go vertical. And for that I'm going to choose upwards as positive. So we're going to have the 5 Newton up and the 2.39 up. So that's going to be 5 plus 2.39. And then this 3.86 is down. So I'm going to say minus 3.86. And if we work this out, we end up with 3.53 newtons. And that is going to be up, because we chose up as positive and we got a positive answer. Now that we know the left and the right, which is 2.52, and we know the up and the down, we can combine them using Pythagoras. Because if we're going to the right and then we're going up, then we can work out this value by using Pythagoras. And so the right is 2.52 and the up is 3.53. So the result to the power of 2 will be equal to 2.52 squared plus 3.53 squared. And that's going to give us, well, I'm just going to square root all in one step so we can square root. That's how Pythagoras works, actually. And to 2 decimal places, we're going to get 4.34 newtons. Now we need to work out this little angle over here. And so we can use reverse trigonometry. So we know that we have the opposite and we have the adjacent. So that'll be tan. So I can say tan, but I must use shift tan. So I'm going to write it like that. Of the opposite over the adjacent. Oh no, I'm making things confusing here. Let's just say tan of whatever the angle is equal to the opposite over the adjacent. And then to get tan, or to get the angle, you must say shift tan on your calculator. And let's call this angle theta. And so what you'll find is that theta is going to be about 54.48 degrees. Now, this angle that I'm measuring is going to be north of the east line. Can you see that? It's north of the east. So I'll say north of east. In question 3, we have to determine the resultant force of these 4 forces. So we've got the 10, 8, 6, and 7. So when we use the head to tail method, we need to have a starting point. So I'm going to start over here, and I'm going to choose the 8 Newton. Oh, but first we should choose a scale. So if I look at the numbers 10, 8, 6, and 7, I can see that a nice scale would be 1 centimeter is the same as 1 Newton. I'm going to start off with this 8 Newton force. Now, guys, you need to be careful. This 20 degrees is measured from this line over here. So I would place my protractor like that. And then you would measure 20 degrees going down like that. And so that would give you a little point over there. And then you would want to draw an 8 centimeter long line. And so there you can see I've drawn my line. The next one I'm going to choose is going to be the 10 Newton force. Actually, no, I'm going to do the 7 Newton force, which goes straight down. And notice that I'm starting at the same place where I just finished with the previous force. And so there I've gone 7 centimeters down. The next force that I'm going to do is the 10 Newton. Now the 10 Newton is going at 40 degrees. So I put my protractor at the same place where I just finished with my last force. And then look at how this 40 degrees is measured. It's measured relative to that horizontal. So it's going to be, I'm going to measure it from here up to there. And so that's going to be 40 degrees. And so there I've positioned my ruler. And so now I can do the 10 centimeter line like that. Now the only force that we still have to do is the 6 Newton force. Now that 6 Newton force is measured at 10 degrees going down. So I'm going to put my protractor upside down and I'm going to place it at the last place that we just finished. And now I'm going to measure 10 degrees going down, which would take me over there. See how I measured 10 degrees like that? And then you can connect a 6 centimeter line. And so it'll take you up to there. And by the way, you might do this in a different order to me. The answer that you get will still be the same. Now that we have finished, we need to measure the distance from the start, which was over here, to the ending point, which is over here. And so if I measure that length from here to here, if I look on my ruler, it's about 6 centimeters. So if you're getting anywhere close to 6 centimeters, then that is good. Now it says that in our scale 1 centimeter is 1 Newton, so it means that the resultant force will be 6 newtons. But now we are not done. We need to measure the angle. So what we're going to do is I'm just going to extend this line a little bit just so I can easily read it off on my protractor, because then I can take the protractor, put it at that starting position, and then I can measure the angle. So I can look, whoops, that was the wrong button, is I can measure this whole angle and I get to about 81 degrees. I would say 81 degrees. So you would say 6 newtons at 81 degrees, but be careful now, that's not the final answer. So what we have is this, if I draw a horizontal line like this and a vertical line, that 81 looks something like that. So you've measured this piece here as 81 degrees. So what do we call this line over here? Well, that is the east line, and you have just gone above the east line. So you are going to say north of east. So we're going to say north of east. Number 4 is the same question or the same setup as number 3, but now we are going to use the component method. So that is where you have to take all the different forces and break them up into vertical and horizontal forces. I'm going to start with the 10 Newton force. So for the 10 Newton force, you would make a little triangle that looks like that. And then you would simply use trigonometry to find the horizontal and the vertical. Just remember that we already know the hypotenuse, which is the 10 Newton. So we already know that. So if I had to redraw that triangle, it would look something like this. And we are going to use SOHCAHTOA, which is our trigonometry ratios. And so let's say, for example, we're looking for x. Well, that's the adjacent, and we already have the hypotenuse. So that'll be cos. So we can say cos 40 is equal to x over 10. And then you can get x alone by multiplying 10 by cos 40. And that'll give us 7.66 newtons. And if you just look at this force, it's going to go more to the left. You can see it's pulling more to the left-hand side. So I'll just add the word left over there. Now we need to find the vertical. So the vertical is opposite the 40 degrees. So that'll be sin, because we're going to use opposite and hypotenuse. So we can say sin 40 is equal to the opposite over the hypotenuse. If you then get y alone, that would be 10 sin 40. And if you work that out, you get 6.43 to 2 decimal places, 6.43 newtons. And if you just look at this force, well, that's going to go up. So there I've summarized the 10 Newton force at the bottom. Next, we are going to do the 8 Newton. So now the triangle that we use would be something like this over here. And I'll quickly draw it out, just that little triangle. So it goes there, there, and there. And the 8 Newton is the hypotenuse. So we can put that as 8 Newtons. Now be careful, guys. This is 20 degrees. So if you minus that from 90, then that means this little corner, which is this little corner, would be 70. Now we can use sin, cos, and tan to try find y and x. So if we find x, that's the adjacent and the hypotenuse, so that's going to be cos. So we can say that cos 70 is equal to x over 8, and then to get x alone, you multiply the 8 and the cos 70 together. And that's 2.74 if you round it to 2 decimal places. And this arrow is pushing more to the right, so we're going to say right. Now we're going to do the vertical, and so that's just going to be sin. So we say sin 70 equals to y over 8. And then you would get that y is equal to 8 sin 70, which is equal to 7.52 newtons. And this arrow is pushing more upwards. Alright, so I've summarized the 8 Newton force at the bottom. The next one I'm going to choose is the 6 Newton. So there's our triangle that we can make. I'll quickly draw that out for us. Where the hypotenuse is 6 newtons, the angle is 10 degrees, and we need to find the vertical and the horizontal and the vertical. So I'm going to go a little bit faster now. It's going to end up being cos 10 equals to x over 6, but please make sure that you understand how I'm getting that. And then if you work out x, it's going to be 6 cos 10, which would be 5.91 newtons, and this arrow is going to the right. Then for the vertical, it would be, so we'll say that sin 10 is going to be equal to the opposite, which is y, over the hypotenuse, which is 6. And then if you get the y alone, it should be 6 sin 10, which would be 1.04, and that's newtons. But now this arrow is actually going more downwards. Can you see that? So that'll be down. And so there I've summarized that. And then guys, the 7 Newton one is very easy. That one does not have a left and a right. It only has a 7 Newton down. Okay, so now we have taken all 4 of those forces and we have broken them up into lefts, rights, ups, and downs. So now what we need to do is we need to find the overall left and right, and then we also need to find the overall up and down. So let's look at the left and right. I'm going to choose all the rights as positive, and we'll call this fx, meaning all the forces in the x direction. That's going to be equal to, this will be a negative because it's to the left. Then this one will be a positive because it's to the right, and I chose right as positive. And then this will be a positive, so that'll be plus 5.91. And if we go work this out, we get 0.99 newtons. And then if I look at the y values, I'm going to choose up as positive. Why am I choosing right and up? It doesn't matter. You can choose your own, but you will still get the same answer. So we're going to have 6.43, which is positive because it's up, plus 7.52, minus 1.04, minus the 7, which is going down. And that gives us 5.91 newtons up, because we got a positive answer. So now we know the right, and we know that it's going up, so it's going to go a little bit to the right and a little bit up. And so to work out the result, I'm just going to fill in these values, and then I simply use Pythagoras to find the result, which I'll call FR. And so if you use Pythagoras, it's going to go like this. It's the square root of 0.99 squared plus 5.91 squared. And that will give us an answer of 5.99 newtons, which is pretty close to the construction answer of 6 newtons that we got in number 3. Now we need to work out the angle. So here's the angle. I'm going to call that theta. And so what you can do, there's many ways to do this, is you can see that we have the opposite and we have the adjacent. So that's tan. So what I can do is I can say tan of theta is equal to the opposite over the adjacent. Now because we're looking for the angle, you must say shift tan on your calculator. So shift tan 5.91 over 0.99, and that's going to give us 80.49 degrees. But look at how we measured that. Can you see that it's going upwards? So it's above, so it's north of this line, which is the east line. So we'll say north of east. But now there are some of you at home who probably did it in a different way. You might have done this. You might have said it's going up and then it's going to the right. And the up is 5.91 and the right is 0.99. Now all of a sudden your angle is over here. Can you see that? That's a little bit different, and it's also correct. So you would say that your tan theta is equal to the opposite, which is 0.99, over the adjacent, which is 5.91. And that would give you, and remember to say shift, that would give you 9.51 degrees, but now you are measuring going like that. So you are going to the right, which means east of this vertical line, which is a north line. And so that's another way you could have answered that. So can you see the similarity here? 80.49 north of east, or 9.51 east of north. 9.51 and 80.49, they add up to 90. So it actually comes down to the following. It comes down to whether you are using this angle or whether you are using this angle. Both of them are correct. In number 5, we have to work out the resultant force and angle using the head to tail method. Now, what you need to identify here is that these forces are fairly big. So what you don't want to do is use a 1-to-1 scale, because you can't draw a 60 centimeter long line. It's not going to fit on a normal piece of paper. So what you do is you'll typically use a scale like 1 centimeter is the same as 5 newtons. And then after that, it's pretty straightforward. So we need to find a starting point, which I'm going to make over here. And then you need to choose a force. So I'm going to choose this 25 Newton. Now 25 newtons is going to be 5 centimeters long, because 1 centimeter is the same as 5 newtons. So I place my protractor at the start and I go up 30 degrees. So that'll take me to here. And then I do a line of 5 centimeters, which would go up to there. I'm now going to do the 35 newtons. So I take my protractor and I place it where we just finished. And I look at the angle of 20 degrees and I see that it's measured like that. So that means I'll go like this up to 20 degrees, so over there. Now 35 newtons, because of our scale of 1 to 5, that'll be a 7 centimeter long line. So there I've already positioned everything correctly, and now I can draw a 7 centimeter line, like that. Next, I'm going to do the 40 newton. Now the 40 newton is nice and easy because it's going horizontally. There's no angle involved. So 40 newton is going to be 8 centimeters long if I use a 1 to 5 ratio. And so there we have an 8 centimeter line. And then lastly, we have a 60 newton line. Now that's going to be 12 centimeters and it's going to go vertically down. And so it should look something like that. We have now done all the forces. And so to find the final result, you need to start at the beginning again, which is here. and you need to measure the length from there to the ending position. And so if I look at that length, I'm getting about 12.5 centimeters. Unfortunately, my ruler doesn't have like all the millimeters showing as well. So I'm getting 12.5 centimeters. But now that is, oh wait, let's write 12.5. That is not the answer, because we don't have a 1-to-1 ratio. So for every 1 centimeter, that's actually 5 newtons. So the newtons is going to be 12.5 multiplied by 5. And that's going to give us 62.5 newtons. You might not get the exact same answer, because with a scale drawing, you can have a little bit of inaccuracy. Maybe mine even has a little bit of inaccuracy. As long as you're getting fairly close, that is good. And then I'm also going to draw in the arrow to show the final result. And so what I do is I connect a dot from the start to the last little point. So we've worked out the force, and now we're going to work out the angle. So I'm going to put my protractor upside down, and I am going to measure this angle over here. There I've placed the protractor, and now I'm going to measure this angle there, and it's going to take me to about 34 degrees. So I'm going to say at 34 degrees, but now you can't just say 34 degrees. You're measuring 34 degrees underneath, so that means below, which means south, of this line over here. Now that is a west line, so we're going to say south of west. Number 6 is the same as question 5, but we are going to use a different technique. Instead of using the protractor and ruler method, we're going to rather use the component method. So remember guys, what that means is we need to take each of these 4 forces and break them up into lefts and rights and ups and downs. So I'm going to start with, and it doesn't really matter which, actually I'm going to start with the 40. It's super easy. I'll show you why. If you look at that 40 Newton, it is not going up or down. It's only going to the left. So literally, all we are going to say for that one is 40 Newtons to the left. So there's the answer for that one. So I'm actually just going to summarize it over here. So the 40 Newton was only 40 newtons to the left. Complete. Now we can do the 60 Newton. So the 60 Newton you can see is just going down. So we can just say 60 Newton. By the way, when I do these things with the line over here, some students in the past, they used to think I was dividing. Guys, what I'm doing is I'm making a little heading. I'm saying this is the 40 Newton one, there's a little heading, and there's the 60 Newton one, and that's a heading. Just so we know which one we're dealing with. And so this one is only going to be 60 newtons down. So that's now complete. The next one I'm going to do is this 25 Newton. So this one's a bit more interesting because obviously it's going at an angle, which means that if I draw a triangle like that, and if I just enlarge that triangle slightly over here, and the 25 is here, then we should realize that this arrow over here is going to push a little bit right and a little bit up. So we need to go find those components now. So I'm going to put an X and a Y over here. And now we use trigonometry. So that's SOHCAHTOA. And so for example, if we look at the 30 degrees and we look at the X, that's the adjacent. And we have the hypotenuse. So that would be cos. So what you would say is cos 30 is equal to the adjacent over the hypotenuse, like that. And then you could get X alone by multiplying the 25 across. So it'll become 25 cos 30. And so X would be equal to 21.65 newtons. Now this arrow is going more to the right. So I'm going to say right. Now we can do the Y. So what you could do there is you could realize that y is the opposite and this is the hypotenuse. So that is sin. So we can say sin 30 equals to the opposite over the hypotenuse like that. And then we can get y alone by multiplying the 25 up. And so we'll find that y is equal to 25 sin 30, which is equal to 12.5 newtons, and if you look at this arrow, it's going more up, so we can say up. And so I've summarized the information for the 25 Newton over here. The last one is the 35 Newton. So I'm just going to draw a little triangle. That triangle would look like that. So I'm going to just redraw it. And so the 35 is the hypotenuse, and the 20 degrees is over there, and we need to find x and y. So it's going to pretty much be the same thing. We're going to realize that cos is going to be used for the x component, and then if you multiply the 35 across, you would find that x is equal to 32.89 if you're doing 2 decimals, and that's going to be newtons. And if you look at this arrow now, guys, here's where you got to be a bit more careful. This arrow would go more to the left. So we're not going to say to the right, we're going to say left. And then we're going to do the vertical component, which would end up being sin, because that's opposite over hypotenuse. So you could say sin 20 equals to the opposite over the hypotenuse, which is 35. Multiply the 35 across, and we would find that y is going to be 11.97 newtons up. And so there we have now taken all 4 of the forces and we've summarized them. So now what we need to do is we need to work out the total left and right and the total up and down. So I'm going to start with the lefts and the rights, which I'm going to call x, and I'm going to choose the right as positive. Why? Just because I feel like it. So what we'll see is that if I start from left to right, or if I start over here, this first one is left, so I'll start off with negative 40. Why negative? Because I chose right as positive, but this one is going to the left. Then the next one is 21.65, which is positive. And then this one is going to the left, so that'll be a minus again. And so calculating this, we'll find that the answer is 51.24, but it's negative. Now, does that mean we've made a mistake? Not at all. It means that we chose going to the right as positive, but we got a negative answer. So what that means is that Fx is actually going to be 51.24 newtons left. Notice we do not have to go and recalculate. Now we're going to do the y's. So we're going to say Fy, and I'm going to choose upwards as positive. And so that's going to be negative 60 for this one, negative 60, and then this is up, which is 12.5, and then this is up, which is 11.97, and calculating this gives us negative 35.53 newtons. Now once again, that's a negative answer. So all that it means is that therefore the y component is going to be 35.53 newtons, but we're going to rather say down, because we chose up as positive, but we're getting a negative answer. Okay guys, so we're nearly done. So now we've got the left and the right, and we've got the up and the down. So now we can do Pythagoras. So if we're going a little bit to the left and a little bit down, then your triangle would probably look something like that. So the left would be 51.24, and the down is 35.53, and so we could use Pythagoras to find this length over here. And I'm going to call that FR because that's the result, and that's going to be 51.24 squared plus 35.53 squared. That's just basic Pythagoras. And so that's going to give us 62.35 newtons. Okay, so there's our answer, 62.35. Which is very similar to what we got when we did the construction method. Now we also need to find the angle. Now there's different ways to find the angles depending on how you draw your triangle. Because you see how I drew to the left and then I drew down? But you might have drawn down first and then to the left. So then look at the angle you're working out. You're working out that angle, whereas I'm working out that angle. Okay, so you might get a different answer to me depending on your angle chosen. At the end, I'll give both kinds of answers that you could have gotten. So I'm going to use this angle. And this is where you use reverse trigonometry. So we have the opposite and we have the adjacent. So that's going to be tan. And so we're going to say tan of theta is equal to opposite over the adjacent. Now, because you're looking for the angle, you're going to say shift tan on your calculator. And so you're going to say shift tan of 35.53 over 51.24. And that's going to give you 34.74 degrees. Okay, so the answer is going to be 62.35 newtons at an angle of 34.74 degrees. Now I need to explain to the teacher how I got this. So I went downwards from the west line. Can you see this line here is called a west line because it's going to the left, and we went below that. So we're going south of the west line. So we say south of west. If you did your triangle in a different way and you want to know if you are correct, your answer would be 62.35 and your angle would be 55.26, but you would say west of south. So if you question 11, we get to the first kind of question where we have an object that is not moving. This object is in equilibrium. They have asked us to use a construction method to determine the force in the rope as well as the weight of the engine. They also tell us that the force is 20 newtons. And that's the chain force. I'm going to say 20 newtons over there. So we need to use a construction. And so what I'm going to do is I'm going to first come up with a scale. Now, you could use 1 centimeter gives you 1 newton. But then just remember you would need to use a full sheet of paper so that it fits in nicely, because 20 centimeters is going to be quite long, but it will work. So let's go. 1 centimeter is going to be the same as 1 newton. Now we need a starting place. So what we should do first with these equilibrium questions is we first need to draw out the situation in a simplified way. I'm not talking about using a ruler and a protractor. You just need to get a rough sketch first. So what we do is we realize that this whole question is centered at the engine. So I'm going to put a little dot here to represent the engine, and then we just put in a whole lot of different forces. So we can see that there's the force of the chain, which would be pulling upwards like that because it's keeping the engine up, so that would go something like that. Then, for example, the next force would be the rope going to the right, and so we almost do like a head to tail, but we're not using a ruler and a protractor, we're just doing a rough little sketch. So the rope would be pushing or pulling to the right, and so I'm going to do that. But we don't know how big it is, so you might think, yeah, well, the line's just going to go like that. But then remember, guys, what we looked at in our introduction videos was that when you have an object that is at equilibrium, it will always make a triangle. Now, we know that the only other force acting on this engine is its own gravity, which will always act downwards. So that arrow cannot end over here, because if you go down from there, you are never going to make a triangle. So what would rather happen is that this arrow would probably go up to here, and then the weight would go down like that so that it completes a triangle. So this over here is the chain, this is the rope, and this is the weight. Now we need to just fill in some angles. So be careful with the angles. It's an area where you can make a couple of mistakes. If you look at the chain, they're telling us that this is 30 degrees. But that 30 degrees, is it with a vertical line or is it with a horizontal line? Well, we can see that it's relative to this vertical line. So if I look at the chain, then I'm not going to put a 30 over here, for example, because that 30 is with a horizontal line. What I'll rather do is put a 30 over there, because now it is with a vertical line. You can see that. I mean, you might be thinking, yeah, but Kevin, isn't that 30 degrees maybe over here? Well, yes, but then if I use alternating angles, then I can see how this is also 30 degrees. Step 1 is now complete. We've gone ahead and we've drawn our nice little diagram and with the angles, and then this would be 90 degrees, of course, and then if you just use sum of angles in a triangle, that'll be 60 degrees. So now we can go and draw this out for ourselves using a ruler and a protractor. So I'm going to start off somewhere over here, and we need to do a 20 centimeter line, and then there's a 30-degree angle. But remember that 30 degrees is measured relative to a vertical, not a horizontal. And so I'm going to rotate my protractor like that and measure 30 degrees, which would take me over there. And so I take my ruler and I put a line going through both of those points, and I measure a 20 centimeter line, like that. So we've now done this force over here. Now I'm going to do the rope. Now the rope is very easy because it's just going to go to the right. Now once again, we don't know how far to the right it's going to go. So for now I'm just going to draw it about that long. Now the only other force that we need is the gravitational weight, which acts downwards. So if I had to go down from here, that wouldn't make sense because it wouldn't complete the triangle. So all that I do is I take my ruler, I make it vertical like that, and then I can connect it to form the triangle. So we now have the chain, the rope, which would end up over here, not this piece, and then the weight. So all I need to do now is measure the length of the rope and the weight. For the rope, I'm getting 10 newtons, or 10 centimeters technically, but because of our ratio of 1 to 1, that's also going to be the equivalent of 10 newtons. And then for the engine, you can see I'm measuring the length of that, and that's about 17 centimeters, which is about 17 newtons. And so that's it, guys. So what we did is we took this diagram, I then simplified it, and then I put that into a proper sketch where I use a ruler and a protractor. In question 12, we are doing the same scenario as question 11, but we are going to be using a different technique. We're going to be using a component method, which is when you should realize that if you have an object such as this engine, which is not moving, then all of the forces to the right must be the same as all of the forces to the left. If that was not true, then the object would either move left or it would move right. You also need to realize that all the forces going up must be the same as all the forces going down. So what I'm going to do is I'm quickly going to simplify the sketch. So the engine, I'm going to make that a little dot. Then I know that there's a force going to the right, which is the rope. Gravity is acting down, that will be weight. And then the chain is trying to pull it upwards like that. And then I know that this angle is 30 degrees, which is this angle here. So if I have to use alternating angles like this, then I should realize that this little angle inside here is 30 degrees. And there we go. So by doing that, it just makes the question a little bit easier to understand. So let's look in the left and right direction. So we'll call that fx, and let's say going to the right is positive. Or we can actually just say that the rope, so the force of the rope, because that's going to the right, must be the same as the force of the chain going to the left. Now you see here, guys, we've got the force of the chain at an angle. So if we make a little triangle like that, for example, then we can use trigonometry to help us work out the horizontal component. Now the horizontal component is this one over here. Of course, if you wanted to, you could also use a triangle like that. It doesn't really matter. And so now we're going to use SOHCAHTOA. And so to find x, and this is 20 because that's the chain, they told us that that's 20. So x is the opposite, the 20 is the hypotenuse, so that'll be sin. So we can say that sin 30 equals to x over 20. And if you get x alone, we would find that that is going to be equal to 20 sin 30. And if you had to go work that out, that would be 10. So the horizontal force of the chain is 10 newtons. So the rope must be equal to 10 newtons. Great. Now we need to look in the vertical direction. So we'll call that Fy. Okay. So what we can say is that all the forces going up must be equal to all the forces going down. So what forces are going up? Well, you can see that the chain, which is this 20 Newton, is going up it's also going a little bit to the left. So we need to work out the vertical component. So we can make our triangle once again. And this can be y and this can be x. Now we just use SOHCAHTOA once again, and we'll see that y is the adjacent and the 20 is the hypotenuse, and so that'll be cos. So we can say that cos 30 is equal to y over 20. And then you can get the y alone by saying 20 cos 30, and so y will be equal to 17.32 newtons. So have a look at that, guys. The chain has a vertical force of 17.32 acting upwards, and so the weight, which is acting downwards, would have to be the same. So the weight is going to be the same as the vertical component of the chain, which is 17.32 newtons. And we can say down over here, and we should have said right over here. Why didn't I use the rope in the vertical? Well, because that rope is not vertical at all. It only acts horizontally. So guys, that is number 12 complete. What you need to understand is that when an object is not moving, then all of the forces going to the left must be the same as the forces going to the right, and all of the forces going up must be the same as all of the forces going down. In question number 13, we are going to do the same question as 11 and 12, but we're using a different technique. Now we're going to use only trigonometry. But Kevin, didn't we use a bit of trigonometry in question 12? Yes, we did, but in this method we use only trigonometry. So what we need to do is we need to take this diagram and turn it into a triangle, like we did in question 11. So I'm going to start off with the engine. And what we should realize is that there are three forces acting on it. There is the gravity, which is the weight, the rope, which would pull it to the right, and then the chain, which is going to keep it up and to the left. So the chain is going to go like that, then the rope is going to go to the right, and then the gravity would have to go directly downwards and complete the triangle. Now, if you look at this angle, that angle is like that. So if we use alternating angles, we can then say that this little angle on the inside here is also 30. Just made that a little bit bigger. So this angle here is 30 degrees. This angle's 90. It won't always be like that, but it's because the rope is pulling exactly to the right like that. So then that can easily help us find out that this is 60, and then the chain is 20 newtons, and this is the weight, and going to the right is the rope. So now we can use trigonometry, and this is where you need to make a decision. If it is a 90-degree triangle, you can use SOHCAHTOA. If it is not a 90-degree triangle, then you would use the last method that I showed you in the introduction videos, which goes like this. If you haven't watched that video, I suggest you go look at that first, otherwise this wouldn't make sense. Now, you only have to use these formulas if it's not a 90 degree. Kevin, can we use these formulas if it is a 90 degree? Yes, you can. But I'm going to use SOHCAHTOA for this example, because it is a 90-degree triangle. And so we know, or let's say we would like to find the weight, and I'm going to use this angle here. So the weight is the adjacent, and the 20 is the hypotenuse, so that'll be cos. So we will say cos 30 equals to the adjacent over the hypotenuse. And so if we go work out the weight, it would be equal to 20 multiplied by cos 30, and that's going to give us 17.32 newtons, and that we could say down. Then to find the rope, we could use 30 degrees again if you would like, and that would be opposite, and the 20 is the hypotenuse, so that'll be sin. So we could say that the sin of 30 equals to the opposite, which is rope, over hypotenuse, which is 20, and if we go work out the rope's force, we will find that it is 20 multiplied by sin 30, and so the rope is going to be 10 newtons going to the right. And that's it, guys. That is what I mean when I say the trigonometry method. If it's 90 degrees, use SOHCAHTOA. If it's not 90 degrees, then we will use this. And we're going to look at those examples in some of our next questions. In question 14, we have an example where we have a system that is not moving. So this is all about equilibrium. In the earlier questions that we did in this worksheet, that was all involving objects that were actually moving. These objects are not moving, and so remember, we should always look out for the triangle when doing a construction. So, step 1, we take this drawing that they've given us and we try simplify it. Okay, so we're not using a ruler and a protractor now, we're just trying to make a little sketch. So, we know that the center of this question is over here. So we make a little dot and we ask ourselves, what forces are acting on that? Well, there's W3, which is gravity, so that would act down. So I just go down like that. W2 is going to be a pulling force like that. So I'm going to go W2. And the angle is very easy, 50 degrees. Then W1 is going to be a pulling force going like that. And the angle is 24 degrees. Oh, and I should label this as W3. Now they've told us that W1 is 50 newtons. Now some of you might be like, yeah, but Kevin, W1 is here. But remember, what we've said is that if the force over here is 50 newtons, it goes all the way through the rope. And so we can also say that the force in that rope over there is 50 newtons. Alright, so there's our simplified diagram. We no longer need this messy diagram. And so what we need to do now is take this and use a ruler and protractor and do a construction, like a head to tail construction. So once again, we need a scale. Now, I don't know about you, but my paper is not going to allow me to use 50 centimeters. So 25 is even going to be a bit of a squeeze. But I think if we say 1 centimeter is 5 newtons, that'll be quite nice, because then we'll have to draw a 10 centimeter line. I wouldn't go 1 centimeter is 10 newtons, because then your diagram's going to start becoming very small, and that's when it becomes inaccurate. This is going to be a 10 centimeter line, so we need to have a starting point. So I'm going to start over here, and I'm going to get my protractor and measure 24 degrees. There we go, and then I measure 24, which is probably over there. And then I need my good old ruler, and then I can draw my 10 centimeter line. Now my 10 centimeters might not look the same as yours because I'm using a digital ruler, but at the end, the answers are all going to be the same. So there's my first 10 centimeter line. Why 10 centimeters? Because we said that 1 centimeter is 5 newtons, and so 50 newtons must be 10 centimeters. Now, we move on to our next force. Now you can choose whatever you like. If you would like to use W3, that's fine. I'm going to choose W2. So W2 is at 50 degrees. Now what some students do, actually a lot of my students do this. They put their protractor like this, and then they try and measure 50 degrees like that. You see, they're trying to measure 50 degrees relative to W1, but that's not what we're doing here. This 50 degrees is measured relative to a horizontal line. So there's where I put my protractor horizontally, and I measure 50 degrees from there. So I can see it's 50 degrees up like that. So I measure up 50 degrees to there. Now you may be sitting at home and thinking, okay, cool, it's 50 degrees, I understand, but I don't know how long that line is. So guys, what you do is the following. You must remember that we are busy with an object that is in equilibrium. And what we also know is that after we do W2, what are we going to do last? Or for the last one, it's going to be W3, and W3 goes down. And we know that it must end off over here. So it means that W2 is probably going to go up, like that, up to about there, so that when you connect it, it goes down. You see, so you don't need to know how long it must be. if you understand that it must complete the triangle and that W3 is going to go down, then it's easy to find out what W2 must do. So I take my ruler and I just draw a line, but don't worry, whoa, that's the wrong button. And then don't worry exactly how long it must be, just make sure that it goes long enough, like that. And then I would put my ruler like that, so we know that gravity acts down, so that's W3, and so it would have to go something like that. You see, so now I know that W2 will only go up to this point, and then W3 will be that one. So now what I do is I just take my ruler and I go measure those lengths. And what I get, and you might get a slightly different answer based on the accuracy, is that W2 is about 14 centimeters. But now remember, that's not the answer. It's not 14 newtons, because 1 centimeter is 5 newtons. So I'm going to multiply that by 5 and end up with 70 newtons. Then W3 is about 15 centimeters. And then if you multiply that by 5, you get 75 newtons. Question 15 is the same as question 14, but we are going to be using a different technique. We are now going to be using the component method. Now remember, if you have an object like this whole system that is not moving, then it means that all the forces going to the right must be the same as all the forces going to the left. Because if it wasn't like that, then the object would move left or right. We also need to realize that all the forces going up must be the same as all the forces going down. So what we do is we take this diagram and we realize that the center is over there, and we make a little diagram for ourselves just to make things a little easier. So we know that W1 is acting in that direction, so we do W1, and that's at 24 degrees. Then W2 would go like that, so we can say W2, and that is at 50 degrees. Then we've got W3, which is just gravity acting downwards. And now they also tell us that W1 is 50 newtons. So this is very easy now. We just need to say that all the forces going to the left must be the same as all the forces going to the right, and all the forces acting up must be the same as all the forces acting down. I'm going to look in the horizontal direction for now, so that's your x direction. And what forces are acting left and right? Is W3 acting left and right? Well, no. W3 is only acting down. So we need to look at W1 and W2. So should we say that W1 is equal to W2? No. Because we have to find the horizontal part of each one. So for example, for W1, if we draw a triangle like this, then we know that there's a horizontal part and a vertical part. We are interested in the horizontal part. So we're going to use normal trigonometry, SOHCAHTOA. And we know that this angle is 24. Let's put it a bit further into that corner. And we know that W1 is 50 newtons. We know that that's 50. So if we're looking for the x component, then we know that that's the adjacent. And we already have the hypotenuse, so that'll be cos. So we can say that cos 24 equals to x over 50. You can then get x alone by saying 50 multiplied by cos 24, and that's going to give you 45.68 newtons, and that would always go left. W1 is definitely pulling to the left. Now we can find the vertical component, which is the y. So the y is opposite, and the 50 is the hypotenuse. So that's sin. So we can say sin 24 equals to the opposite over the hypotenuse, which is 50. And so if we had to work out y, that would be 20.34 newtons up. So I'm going to go fill those in on our diagram now. So to the left, we said it's 45.68 newtons, and going up is 20.34. Now we need to repeat this process for W2. So I'm just going to draw this angle further into the corner, like that. Okay, and once again we should try work out its x and its y, and then W2 is over there. But Kevin, we don't know how big W2 is. Yes, I know, but it's okay. We're just going to do it like this for now. We know that there's this 50 degree. We would like to find x, which is the adjacent, and we pretend that we have W2, which is the hypotenuse. So that'll be cos once again. So what we do is we say cos 50 is equal to the adjacent over the hypotenuse. Then to get x alone, it's going to end up becoming W2 multiplied by cos 50. So just leave it like that for now. I'm going to fill it in here, W2 cos 50. Then to find the y component, we know that that's the opposite, and W2 is the hypotenuse, so we can say that that is sin. So we say sin 50 equals to y over W2. And if we had to get y alone, it's going to be W2 multiplied by sin 50, and I'll fill that in the place of y. Now comes the easy part. So, which forces are acting to the left? Well, that would be this one. Can you see that? It's going to the left like that. And which forces are going to the right? Well, that would be that one. So those two would have to be equal to each other. So we can say that 45.68 must be equal to W2 cos 50. Then to get W2 alone, I would just say 45.68 over cos 50. And so W2 is going to be equal to 71.07 newtons to the... Oh no, we're not going to say to the right because W2 is acting at an angle. Okay, so we've worked out W2, 71.07 newtons. Now, in the vertical direction, so in the up and the down, what forces do we have? Well, we've got the 20.34 going up. We've also got W2 sin 50 going up. Can you see both W2 and W1 are acting upwards, and then W3 is acting down. So all of the ups must equal to all of the downs. So we can say that 20.34 plus W2 sin 50 equals W3. If you are understanding this right now, then well done to you. That is amazing. So we can say that 20.34 plus, now W2 we already found as 71.07 sin 50. And that will be equal to W3. Then all of this on the left hand side, I can just type it in on my calculator. And that's going to mean that W3 is going to be equal to 74.78 newtons. In question 16, we are doing the same scenario as 14 and 15, but now we're going to use trigonometry. So we know that W1, or what we said first, if you haven't watched number 15 and 14, is that we should first simplify the diagram. So we take this center piece over here, we realize that W1 is operating in that direction, so we can go like this, W1, and then W2 goes upwards like that, and I've been forgetting to put the angles in, that's 50 degrees, and this angle over here is 24 degrees, like that. And then of course W3 would just act downwards. W1 is also 50 newtons. Okay, so what we've done is we've just taken this diagram and we've simplified it, so we can actually just scratch it out. But some of you at home watching this might actually be looking at that, so I'm not going to be rude and do that. So there we go. But once again, we don't need to use this. Okay, let me take that off again. So we're going to be using trigonometry. So what we need to do now is we need to construct a little triangle. But you don't need to use a ruler and a protractor. That's not what I'm saying. So I'm going to start here and I'm going to do W1. Okay, so we know that that's 50 newtons. Now check this out. We know that this angle here is 24 degrees. The next one I'm going to do is W2. Now I know that W2 will go something like that. I don't know how far it must go, but that's okay because I know that the next one is W3, and W3 goes down. So if I go down, that's not going to work because it's supposed to complete the triangle. So all that I do then is I just do something like there. Okay, and then I scratch that out. See how I'm not using a ruler, I'm just drawing a quick little diagram. This is my favorite method, it's the fastest. that's W2, that's W3, and this is W1, which we know is 50 newtons. So guys, this is how this next part works. What we can do, and some of my students have become quite good at doing this, so what you can do is you can put this dotted line here. So if you use alternating angles, which is like that, then instantly we know, or we should realize that this is 24. Then look at W2 over here. Look at its angle. It is elevated at 50 degrees from the horizontal. So that would be this little angle over here. Can you see that? So then we can just add these two angles together and just say 74. And so that'll be 74. And then if this whole block over here is 90, then of course we can work out this angle by just saying 90 minus 24. And I think that'll be 66. Then we can use the sum of the angles in a triangle to work out this angle. If you do that, you would find out that that angle is going to be equal to 40. And so there we go, guys. Everything is sorted. So now we use trigonometry, where we have two options. You could use SOHCAHTOA, but you can only use SOHCAHTOA if it is a 90-degree triangle. If it is not a 90-degree triangle, then we are going to use our new formula like that. And remember, I made a video explaining how this formula works. If you haven't watched it, you should go have a look at that. So the way it works, it's a really nice formula. You need to find a side, so for example 50. Now that angle 50 is opposite which angle? Is it opposite the 74, the 66, or the 40? Well, it's opposite the 40. So it's opposite sin 40. So we'll say 50 over sin 40 equals to any other side. So for example, W2 over its angle. Now its angle is 66, so that's sin 66. So I'm just going to rewrite that over here. And so then what you do is you need to get W2 by itself. And so we will do that by multiplying the sin 66 across. So it's going to end up giving you 50 over sin 40 multiplied by sin 66. And so W2 will be equal to 71.06 newtons. Now we just repeat the same process to find W3, and you can use any two sides. So for example, I'm going to use 50 again. So we know that that goes with sin of 40 equals to, now this time we're going to take W3 over its angle, which is 74. So we say sin 74. And so I'm going to quickly rewrite that. So that's 50 over the sin of 40 equals to W3 over the sin of 74. And then if I have to get W3 alone, you would have to multiply the sin 74 across. And so that's going to be 74.78 newtons. And so that's the end of number 16. In question 17, we have to use a construction. So that means protractor, ruler, and all of that. Now, what I would always do is I would take this diagram and I would try simplify the drawing first. So this would be my centerpiece over here. So I'll draw a little drawing for myself, just a quick little sketch. Then I can see that there are a couple of different forces here. We've got T1, let's call this one T2. So T2 is going up like that. T1 would do something like that. And then W would obviously just go down. Now, with regards to the angles, we can see that this angle here is 30. So by using alternating angles, we can work out that this will also be 30. And then the same approach can be used for the 60 degree. If we use alternating angles, we will find that this angle here is 60. Alright, so now we can begin construction. Oh, and we know that T1 is 96. Okay, so now we need to choose a suitable scale. Okay, this takes a bit of trial and error, but I'm going to go with 1 centimeter equals 6 newtons, because then 96 newtons would be about 16 centimeters. So I'm going to choose a starting point, and I'm going to start with T1. So I need to get a protractor and measure 60 degrees. So there we go, we're going to measure 60 degrees, which will take us over there. And then we need a ruler to draw a 16 centimeter line. And so there we go. There is my 16 centimeter line. Okay, the next one I'm going to do is going to be W. I would sometimes do T2, but I see there's a bit of a problem coming, because if I do T2 now, it's going to go off the page. So you can be a bit clever about this, and you can avoid that by using W next. Now I know that W, and by the way, it would have been better if we could have gone that way, but it's not going to work. So I'm going to choose to do W. Now I know that W is going to go straight down. Now I don't know how long it's going to go, but we're just going to go down. We know that gravity acts downwards, and so there we go. Let's stop there. That's about as far as my page can go. Alright, so now what are we going to do? So we know that somewhere on this line we would have to do T2, right? Because that's the one that we haven't done yet. So if T2 starts here maybe, then we would have to let it go upwards at an angle of 30 degrees, and because of that, this 30 degrees over here, and it would, if we've done it perfectly, it would have to connect back to the starting position. So if we see that that's not working, then we maybe try a point down here, and then we try 30 degrees again, and we keep going until it works out perfectly. So of course we need a protractor. So here's my protractor, and I'm just going to slide it up and down this line until, and then keep your eye on this 30 degree mark. See, I got a 30 degree over there. So if I do it there, for example, that's not going to work, but if I do it there, can you see that? Then that is going to go in a 30 degree line, because if I go along this line here, that's the 30 degree, and it goes right through to the beginning point. And so I need to make a little mark where my protractor was placed, which is over there. And now I can get a ruler and just make it more tidy, like that. There we go. So that would have to be T2. And so now remember, just ignore these little cutoffs over here. And so now what we can go do is measure everything. So this one here is T2, and this one here is W. So we need our ruler again. Place the ruler like that, for example. And if we measure W2, it looks to be about 18 centimeters. So I'm just going to go with 18 centimeters. But then remember that 1 centimeter is 6 Newton. So W is going to be 18 centimeters multiplied by 6. And that's going to be 108 newtons. In fact, if I look carefully, it's probably like 18.3. Yeah, I'm going to go with 18.3 rather. And so that's about 109.8 newtons, somewhere around there. In question 18, we are going to do the same setup as question 17, but we are now going to use the component method. Now, the way that the component method works is we need to understand that this object, this block, is not moving. So what that means is that all of the forces that are going to the right must be the same as all of the forces going to the left. Because if that was not true, then the object would move left or right. In the same way, all of the forces going up must be the same as all of the forces going down, because if it wasn't true, then the block would move up or down. And so what we are going to do for step 1 is we're going to take this drawing and we're going to simplify it for ourselves. So we're just going to do a rough little sketch. So this becomes the center of the diagram. And then what we have here is we've got this force pulling upwards like that, which is T1. And then we've got this force going up here on the right hand side, which I'm just going to call that T2. So we'll go like that. And then we've got W, which is the weight due to gravity, which is going to go down. So there we've got our 3 forces. Now we need to put some angles in. So if I use alternating angles over here, then I know that this corner angle is 60. So that would be this angle here, which will be 60. And then I can use alternating angles over here, and you would find that that little corner angle would be 30 because of alternating angles. So that would be this one, like that. Now it's quite straightforward. Because we're using the component method, we are going to take each of the forces, T1, T2, and W, and we're going to work out the components. And so this is where you would use normal SOHCAHTOA kind of trigonometry, where it looks like this. And so let's just draw that triangle for ourselves. So it's T1, 60 degrees, and then we need to find the X and the Y. So, and we know T1. T1 has a value of 96. Let's actually fill that in over there, and I'll fill it in over here as 96 newtons. So we're going to use normal SOHCAHTOA to find X and Y. So for example, if we start with X, we know that that is the adjacent, and we have the hypotenuse. So we can say that cos 60 is equal to the adjacent over the hypotenuse. Why am I saying 60, guys? It's 96. And then if you had to take if you wanted to get X, you would have to take the 96 across, so it would be 96 cos 60. And what we'll find is that X is going to be equal to 48 newtons. So this little one here is 48 newtons. And that would go to the left, because if you look at the way that this arrow is operating, it's going a little bit to the left and then a little bit upwards. Then coming back to this triangle, we can find Y by going opposite over hypotenuse, which is sin. So we can say that sin 60 is equal to the opposite over the hypotenuse, which is 96. And so if you had to solve that, you would find out that it's 96 sin 60, and so Y would be equal to 83.14 newtons. And so we can fill that in on our diagram, 83.14 newtons. And that's going to go upwards, of course. And guys, this is why we call it the component method, because we're taking the 96 and we're breaking it up into its horizontal and vertical components. So now we're going to look at T2. So T2, we will have this triangle. Well, first of all, we know that T2 is going to go more to the right and then up. So let's draw ourselves a little triangle for T2. I'm going to draw it up here. Now we know the angle is 30 degrees. We know the hypotenuse as T2. And once again, we're going to try to find its X and its Y. So I'm going to start with its X, so that's the adjacent, and we have the hypotenuse. But some of you are like, Kevin, we don't have the hypotenuse, it's T2. Guys, just pretend you have it, and you'll see how it all works out later on. So we're going to say cos 30 equals to the adjacent over the hypotenuse, and then to get the X alone, you just multiply the T2 across, like that. And so you can't go any further than that, so we'll just fill that in on the diagram as T2 cos 30. Of course, you could work out cos 30 if you wanted to, but I'm going to leave it for now. And then I'm going to work out the opposite. So that's going to be opposite over hypotenuse, which is sin. So we're going to say sin 30 equals to y over T2. Then to get y alone, you're going to say T2 multiplied by sin 30. And then I'm going to fill that in on the diagram over here. Okay, now we don't need to do anything for W because W is acting down. So it's not going left or right or anything like that. So what we can now realize is that all of the forces going left. What are all of the forces going left? Have a look on the diagram carefully now. Well, we've broken the 96 up into this 48 going to the left. So we can say that that 48 must be equal to all of the forces going to the right, which is this one over here. Can you see that? It's quite easy. Then you can get T2 alone by saying 48 divided by cos 30. And so T2 is going to have a value of 55.43 newtons to 2 decimal places. Okay, so we now have T2 as 55.43 newtons. Now we are going to look in the vertical direction. So all of the forces going up must be the same as all of the forces going down. So look at the forces going up. There's this one, there's this one, and then all of the forces going down will be W. So we can say that 83.14 plus T2 sin 30 must be the same as W. But now we have T2, so we can fill that in. So it's 83.14 plus 55.43 sin 30 equals to W. And so now it's just a matter of typing everything in on the calculator. and we'll find that W is going to be equal to 110.86 newtons. And that was the question that we were trying to solve, and so that's the end of this question. In question 19, we have to work out the force of W using the trigonometry method. And so what I would always do is I would first take this diagram and simplify it. So I know that the center of the diagram is there, so I'd put a little dot over here. And then I'd look at all the forces. So there's this force going in that direction, which is T1. Or, though, let me rather fill in the value, because we have the value as 96. Then I would call this one T2. They would usually give that to you in the exam. They'll tell you what it's called. So that'll be T2. And then we've got W going downwards. So now we don't need this diagram, okay? But I'm going to leave it. I know some of you probably like to look at the diagram. So now we need to fill in the angles. So we can do alternating angles over here and would realize that this is 60 degrees. So that means this angle inside here is 60 degrees over there. Then we can use alternating angles for this one and would get 30 degrees, like that. Now it's a case of doing trigonometry. So what we're going to do is we're going to do a quick little diagram for ourselves, almost like a head to tail, but without a ruler or a protractor. Just a quick little diagram. So I'm going to start with this one over here, the 96. I know that it goes off at 60 degrees, so I'm going to do something like that. 96 with a 60 degree angle. Then I'm going to do a head to tail onto that. So the T2 is going to go off at 30 degrees. So that's going to be something like that. But I don't know how much T2 is or how far it is. But I know that this angle is 30 degrees. Then I know that W acts down, and I know that because this object is not moving, this diagram here on the right should form a triangle. So if I go down from here, that's not going to work, because that's not going to make a triangle. So it's probably going to have to go downwards from over here. And then if you go down, 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 there we go. And so there we have our triangle, where this will be W, and this over here, we'll call this one T2. Now, the angles are quite easy. Check this out. We know that this is 60, so if we do alternating angles, then this little angle over here is 60. What that means is that this whole angle is 90. So I'm going to put it at 90 over there, and then I can see here that that's a 90 degrees, so that means this little angle would be 30. Then if I just use the angles in a triangle, I would be able to work out this as 60. Now we use trigonometry. Now this is where you need to look at your triangle. If your triangle has a 90 degree, then you can use SOHCAHTOA. You know, like in grade 10. If your triangle does not have a 90 degree, then you need to use the new formula that we've learned in grade 11, which goes like that. You could technically use this for any of them, even if it does have a 90 degree, it doesn't matter. But I'm going to use this one here because it does have a 90 degree. So, I would like to be able to find W, and I know that this is 96. Now you can use the 60 degree or the 30 degree. I'm going to use the 30 degree just because I feel like it. It doesn't matter if you want to maybe choose the 60, you will get the same answer. And so from that 30 degrees, we have the hypotenuse, because it's opposite the 90, and we have the adjacent. So that's cos. It's adjacent and hypotenuse. So we're going to say cos 30 equals to the adjacent, which is 96, over the hypotenuse, which is W. We're then going to get W alone. Now this one's a little more tricky because W is at the bottom. So what you do is you multiply W across like we normally do. Then what you need to do is divide by cos 30. So you're going to end up with W equals to 96 over cos 30. And that's going to give us a value of 110.85 newtons. In question 20, we have to work out the force of F1 and F2 using a construction. So remember, your construction is all about protractor and ruler. But what I would do first, guys, and it's very important, is you need to redraw this in a more simplified way. So the center of this entire question is going to be over here. So I'm going to make a little dot over here. Now, what forces are acting on that point? Well, there's the downwards force of this 400 Newton. That's gravity going down. That's 400 Newtons. Then, I want you guys to look at this very, very carefully. If you look closely at this pole, what is that pole doing to that point? Is it pulling or is it pushing? Look at how the string is going around it like that. So if that pole was not there, then this entire object would swing that way. So that pole is keeping the 400 away. Can you see that? That pole is pushing it in that direction. So the pole, which is F2, is actually going to go in this direction, okay? It's very important that you see that. And it's a 20-degree angle. Now, look at this piece of string over here. What is that doing to this point? Well, that string is going to keep the object from moving away, so it's keeping it going to the left. So it's going to go in that direction. You can't say that it's also going in this direction, because then the object would move to the right. The arrows would not balance out. And that angle is 45 degrees. And so there we go. Now we can easily go ahead and do our scale drawing. But remember, we need a scale. So they're saying 400 Newtons. So we could probably say that 1 centimeter is 40 Newtons. Because then our line only has to be 10 centimeters. So what I'm going to do is I'm going to start off with the 400. So I'm going to start somewhere over here, and I'm going to draw a 10 centimeter line going down, because that will represent 400 Newtons. And so there you can see I've drawn a 10 centimeter line. Now the next part I'm going to do is F2, which is going to go off at 20 degrees. And so I'm going to measure 20 degrees like that, because I can see that it's measured 20 upwards. But I don't know how long the line is, but that's okay. I'm just going to draw a pretty long line. See, so I'm just going to draw a long line. I'm sure that'll be enough. Now, I know that the only force that I have to still do is F1. And F1 goes at 45 degrees, and it must end up over here. So for example, you might think that it's going to start over here, and then when you measure 45 degrees it does that. Well, that's not good enough, because it's supposed to end up at the top here. Then you might choose this one and you go 45 degrees and it goes too high. So you need to just try a few different points. But you can get pretty close by just taking your protractor and then keeping your eye on the 45 degree mark, which is over here. Okay, so keep an eye on that point and we can try eyeball it. So I'm going to move somewhere down, 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 up, probably around there. Can you see that? Maybe a little higher, somewhere around there. So now what we can do is take our ruler and make sure that it will work. And that actually works perfectly. Let me show you why. I'm putting my ruler at that point. I'm going through 45 degrees. Can you see here it says 40 and then there's a 5 over there. So I'm going through the 45 and then it goes through this point perfectly. And so there we go, I've connected it all up. And so my triangle actually stops over here, so we don't need this piece. And so we must remember that this is the 400 Newton. This was F1 and this was F2. So now the question says determine F1 and F2, so we can easily do that by measuring the lengths using our ruler. So if I look at F1, it appears to be about, now as I said in previous questions, that this ruler isn't the best that I'm using, but it looks to be around 10.6. But now I know that the proper answer is supposed to be more about 10.3 or around 10.4. So you should look for about 10.3 centimeters or somewhere around 10.4 centimeters. I must have gone off a little bit. And remember that that's not the final answer, because you'd have to multiply by 40. So if it was 10.3 and you multiply that by 40, then that's going to be about 412 newtons. And if you got 10,4, then it's about 416. So try get as close to that as you can. Of course, you are going to make a few mistakes. The protractor and ruler method, you can get a little bit off, but the teachers do understand that, and you don't have to get it absolutely perfect. And that was for F1. Now for F2, then when I measure the length of F2, so I took my ruler and I measured F2, I got about 7.9 centimeters. So if you multiply that by 40, because of the scale, you get about 316 newtons. Now yours might be a little bit different to mine, which is absolutely fine. The perfect answer is 312. That is like the correct mathematical way. So in summary, F1 is approximately somewhere between 412 and 416 newtons, and F2 is somewhere between probably 310 and 314. So try get somewhere close to that. In question 21, we are going to use the component method. But first, we should always try take this diagram and turn it into something that looks a little bit easier. So the center of the question is going to be there. So I'm going to make a little dot. Then I know that there's a force going down, which is gravity of 400 newtons. Now guys, have a look carefully at this pole. What is this pole doing to this point? If you look carefully, you'll see that the string or the rope is going around the pole. So what that pole is doing is it's keeping the string going in that direction. It's pushing the string away, so it's going in that direction. Okay, and the angle is 20 degrees, and the force there is F2. We don't know what it is, so we'll just call it F2. Now, what is this piece of rope here doing? Well, that's sort of it's pulling to the left, so it's going in that direction, and that angle is 45 degrees. Now we're going to use the component method, which is where you need to get every single force into its horizontal and its vertical. And we do that by making simple little triangles like this. We call it X and Y. And then of course we're going to do the same for this one, and that'll be its X and its Y. And then for the 400 we don't have to do anything, because it is only a vertical force. So I'm going to start with this triangle here on the left hand side, and I'm going to draw a little triangle for us over here, where this is F1, 45 degrees X and Y, and we're going to use SOHCAHTOA. So I'm going to start with X. So we know that X is the adjacent, and we have the hypotenuse, so that's cos. So we're going to say cos 45 equals to X over F1. And it doesn't matter if you don't know what F1 is, it's okay. So you're just going to get X alone now. So X is going to be equal to F1 multiplied by cos 45. And I can now go fill that in on the diagram. So this is going to be F1 cos 45. Then I'm going to try find the opposite, which is Y. And so that's going to be opposite over hypotenuse, which is now sin. So I'm going to say sin 45 equals to the opposite over the hypotenuse. I then get Y alone by multiplying the F1 across like that. And so we can say F1 sin 45. Now I'm going to move on to the next triangle. So I'm going to do this triangle over here, and so I'm going to draw it out for us like that, where this will be X, this will be Y, this will be F2, and this is 20 degrees. So now it's the same thing. We're going to use SOHCAHTOA once again. So we know that X is the adjacent, F2 is the hypotenuse, that's cos. So we're going to say cos 20 equals to X over F2. We're then going to get X alone, which will be f2 cos 20. I'm going to go fill that in on our diagram now as f2 cos 20. Now we're going to do the vertical component, which is y, and so that's going to be opposite over hypotenuse, which is sin. And so we can say that sin 20 is equal to the opposite over the hypotenuse, and then we can get y alone as f2 multiplied by sin 20. I'm going to fill that in. So f2 sin 20. And that's it, guys. Now, what we need to understand is that if this object is not moving, then it means that all the forces going to the left will be the same as all the forces going to the right. And all the forces going up must be the same as all the forces going down. So I'm going to start with the left and the right. What forces are going left and right? Well, you should identify that F1 is actually going left and up, and F2 is going right and up. So the left is going to be, so the left and the right is going to be F1 cos 45 will have to be exactly the same as F2 cos 20. What I'm saying is that this force must be the same as that. Because if it's not, then the object is going to move either left or right. But now, Kevin, what are we going to do? We've got F1 and F2. Guys, it's absolutely fine. We can't do anything. This is quite a difficult question, so we won't do anything at the moment. There's two unknowns. You cannot solve that mathematically. So now what we do is we'll just call that equation number 1, and we'll leave it alone for now. Now we're going to move on to the verticals. So we can say that all the upwards must be equal to all the downwards. So all the upwards would be F1 sin 45 plus F2 sin 20 would have to equal all the downs, which is 400. Now, can you guys see what happens? We have two equations with two unknowns, and so we're going to do this simultaneously. Now, don't be afraid or concerned. I know it looks intimidating with all the sin and the cos, but I'll show you it's actually quite easy. So what we can do is try get F1 or F2 alone. So I'm going to take this equation, and I'm going to get F1 by itself. I do that by simply dividing by cos 45. There we go. I now have F1 by itself. I'm now going to take that and plug it into F1 over here. So in brackets, I'm going to plug in F1 as F2 cos 20 over cos 45. And then that's only F1. So remember that there's also the sin 45 plus F2 sin 20 equals to 400. Now what you can do is you can type all of this. Let me do it in a different color. All of this can be typed in on your calculator. It's all just one term. So you can type in cos 20 multiplied by sin 45 divided by cos 45. And that's going to give you 0, I'm just going to keep the first 3 numbers on the calculator, or actually the first 4, just to improve the accuracy a bit, because this isn't the final answer. So I'm going to go 0.9396, and then that F2 is still over there, so I'm going to put F2 plus, now this, if you type in sin 20, that's also just a number. So type sin 20 on your calculator, and it's going to give you 0.3420 F2 equals to 400. Now you can just add these two together, so it will be 0.9396 plus 0.3420, which gives you 1.2816 F2 equals to 400. You can then get F2 alone by dividing by 1.2816, and that's going to give you 312.1 newtons. Now I can round off to 2 decimals, which will actually be 0.11. Now all I do is I plug that answer for F2 into here to get F1. Makes sense, right? So we say F1 is going to be equal to 312.11 multiplied by cos 20 over cos 45. Go ahead, type that in, and so that's going to give us 414.77 newtons for F1. In this question, we are going to determine F1 and F2 using trigonometry. So what we're going to do first is just take this diagram and simplify it. And so what we can do, for example, is realize that that is our center. And so there's a 400 newtons going down. So I'm going to do 400 newtons going down like that. Then, guys, you need to look at this pole carefully, this pole over here. What is that pole doing to this point? Well, that pole is pushing that point away like that. Okay, can you see it's pushing it away? So I'm going to show it like that, and it's elevated at an angle of 20 degrees. And then force F1 is this piece of rope. What is that rope doing? Well, it's keeping this point to the left. So it's going to go like that, and that'll be F1. I should have labeled this as F2, and this angle here is 45 degrees. Okay, so now we've got a nice simple diagram, so we don't have to use that anymore if we don't want to. So now, because we're using the trigonometry method, we need to draw ourselves a little triangle. But remember, you don't need to use a ruler and a protractor, because that is a different method. So I'm going to start here, and I'm going to do the 400 newtons. So it goes down, but I don't have to use a ruler. Remember that. You don't have to, so that's 400 newtons. Then the next force I'm going to do is F2. So I know that F2 does something like that, where this angle here is 20 degrees. And then what I'm going to do is I'm going to finish up with F1, which would probably start somewhere here, and it goes in that direction over there. And I know that F1 is elevated at 45 degrees, like that. Then what I can do, because I need to work out all the angles, is I can use alternating angles over here, and I can find that this is 20 degrees. And then if this angle was 20 degrees, and this is a 90, then it means that this little angle over here is 70. Then what I can do is realize that this is 70, this is 65, so I can use sum of angles in a triangle to find this angle. And that angle at the top is 45 degrees. Now, you need to look at this triangle that you have just made. Oh, and something I want to highlight to you. Notice how we had a 20 over here. Notice that that 20 is not even on this diagram. So you need to be careful. You want to always be able to take this information, simplify it to something like this, and then redraw your triangle. Now look at your triangle that you've just drawn. Because it's not a 90-degree triangle, you have to use the new formula that we've learned, which is A over sin A equals to B over sin B. And I'm going to take this 400 as my A, and then 400 is opposite the angle 65, so it'll be 400 over sin 65 equals to, oh, and I didn't even fill in my values, F1, F2. I'm going to find F1 first, so we're going to say F1 up here over the sin of the angle opposite F1, which is 70. Then to get F1 alone, you're just going to say 400 over sin 65 multiplied, because I'm taking this up to the top, by sin 70. Let me do that a little bit neater. So it's going to be multiplied by sin 70. So you're then going to type that on the calculator, and you'll find that F1 is going to be 414.73 newtons. Now I'm going to repeat the process for F2. So I'm going to use the 400 and the sin 65 again, just like I did over here. So I'm going to say, let me do this in a different color. I'm going to say 400 over the sin of 65 equals to F2 over the sin of its angle, which is 45 degrees. Then, to get F2 alone, it's going to end up being 400 over the sin of 65 multiplied by the sin of 45 equals to F2. And so if you eventually go ahead and work that out, you would find out that F2 is going to be equal to 312.08 newtons.